Hello, this is Mahendra Didia. In this portion of the book on liquid formulation, we continue to cover solution formulations using integrated approach to formulation development. This seventh module builds on information that was covered in previous modules on composition and formulation. Manufacturing of a liquid product involves batch formula where all ingredients amount in the product is listed. A procedure or instructions of how to make the product, and very important is the equipment needed to make the product. Manufacturing also includes verification of the procedure and product quality. This is achieved by establishing in-process and final product quality test. The quality of the product is covered in Module 8. These are two different aspects of manufacturing where if either the equipment or the instructions fail to perform, the entire product fails. We can write a procedure whereby a solute is dissolved by heating of a solution. In laboratory batch, glass beaker and a hot plate with magnetic stirrer is adequate. So equipment and process are interrelated. It is important to develop laboratory batch processes so that the process can be transferred to a commercial batch scale. The first related video of Module 7 is on equipment, and the second related video submodule looks at the process with an example of a batch manufacturing from a laboratory scale to commercial scale. Food and Drug Administration and other regulatory agencies have established guidelines for manufacturing process. This is covered in a FDA documentation, and there is a specific format that is used, batch formula. Batch formula lists all the ingredients and their amount used in the manufacture of a representative batch of the drug product. So for a small scale, early phase, it will be a smaller scale batch. As the development progresses, a commercial batch record needs to be provided. From a small batch to the commercial batch be integrated, which allows scientists to see how the product was developed. Manufacturing and packaging process for a representative batch. This includes description of each production step: heating, mixing, cooling, preparing of a solutions, portion of the product. It requires actual operating conditions and, importantly, equipment that will be utilized in production of a representative batch and sampling points for in-process control. In addition to that, schematic diagram of the production process should be included. This includes equipment use. These three constitute manufacturing of the product: batch formula, manufacturing instructions, and equipment. Flow diagram to explain the process. So first look at processing equipment. It is critical for a scientist to understand what would be the manufacturing commercial level process, and based on that, develop small-scale laboratory batches. If we don't understand what manufacturing requirements are, we will develop a product at a lab scale, which will be difficult to transfer. It will require more studies. Major processing step in a solution formulation involves mixing of an ingredient in a sequence. Solutes that we want to dissolve and solvents to make a uniform solution. In addition to that, we adjust pH, we use auxiliary agents, filter the product, coloring and fragrance is added. That needs to be included in the manufacturing step. At various stages of manufacturing, weight and volumes will be checked. Solution formulations are filtered at final step and they are packaged. processing steps will depend on the product and the material characteristics. Developmental stages, processing materials, equipment should be compatible with the commercial equipment. And we'll point that out during presentation. Let's look at solution manufacturing. Example of a liquid syrup is used. The liquid syrup solutions contain sweeteners, sugar, and material dissolved in water. This mixer should be able to heat and cool with steam or with hot water. Sugar and sugar materials are dissolved and filtered. Main mixing vessel contains heating and cooling, a mixing shaft, and materials are added depending on the procedure. Material be able to recycle so that mixing is uniform. The last step, once the product is made, is to pass it through a mill or homogenizer, if required, into a storage tank. Storage tank generally does not have intense mixing. This is common for most of the solution manufacturing. We may have more equipment depending on the product. All these equipment is generally washed. So next thing we want to focus is mixing it. Mixing is important for solution manufacturing as we dissolve solutes into solvent. It is the critical stage for manufacturing of liquid product. Mixing is done with an intent to make content homogeneous. Improper mixing will result into poor quality of product, or it will take longer time to mix. In this video, we will see a condition that's not favorable to a good mixing and is used in manufacturing. In a laboratory, we need to look at what would manufacturing operate and reproduce that into a developmental batch. There are several ways you can put a shaft, and depending on how the shaft is positioned and the intensity of mixing, product will mix. A common way is to provide a vortex. That's not necessarily adequate depending on the density of the solutes. In this case, there's a vortex, but the solute, because of its density, stays at the bottom and does not mix well. There is not enough mixing, as you can see here. To look at vortex very carefully in a laboratory mode where we can use a clean beaker. If we can avoid vortex, we'll have a better mixing. Filtration equipment. There are many types of filtering. During formulation development, at small scale, should use same filtering membrane as used in a commercial process. Filter housing may be too big to process a small scale batch. However, there are smaller filters that can be used with similar material that will allow scientists to look at the adsorption of a drug or a solute on the filter membrane. Solutions are filtered to remove fine particulate materials introduced during manufacturing. Filtration should never be used to remove undissolved solutes or active. Undissolved solutes means process is not robust. Sterile products are filtered through 0.1 micron filter, and the filter cartridges or filtering system must be capable of sterilization. So let's look at filtration technique that is used in manufacturing. So generally there is a membrane with a pleated surface, and liquid goes up from the bottom and discharged from top. So liquid is introduced here, and with the particulate as shown. and the particulates retain inside and clean permeate comes out. Very important in manufacturing. Generally, we do not look at it in a laboratory mode, is mixing volume or total and useful working volume of the mixer. In this reference, Mastering Mixing Fundamental, engineering models are provided. So for scientists, it's important to know that total capacity of a mixer, generally presented in liters, that entire capacity is not available for efficient mixing. Efficient mixing will depend on the product, viscosity, other factors. Minimum working volume is about 40% of the total volume. Again, it depends on the formulation. Volume of less than 15% will not be sufficient, as propeller of the mixer will not reach the bottom and will not agitate. Agitation is a circular motion. So minimum working volume of about 40% at a moderate speed will provide this circulation motion. Maximum volume is generally about 70% of the total volume. Beyond that, mixing action will not be efficient and product will not mix properly. In addition to that, motor, gear, powers are extremely important. And engineers will be involved in advising of the power consumptions. If the viscosity is high, it will require more power to move the liquid. All these things need to be understood by formulation development scientists when you are developing a lab scale batch. And commercial scale batches can be larger scale in thousands of liters.